Welcome to the presentation by T4M5 on what we created in our box. The team members of this group were Sean, Jay, Davia, Terminus, Devon, Daniel, and Harry.
Working collaboratively in teams, we have been tasked with designing and assembling a marble machine box. To outline how we achieved this, we will discuss these areas: problem statement, physical design, circuit design, implementation, integration, reflection, and the final product.
The client requires a marble machine cube which accepts marbles in the top and deposits them at the bottom. The marble must move in multiple directions, retrace its path for a minimum of 5 cm and stop for a minimum of 1 second before moving again. It must actuate lighting in the form of LEDs as it moves between the entry and exit points, and it must rotate around a fixed axis within the box.
To achieve what is stated in the problem definition, our group first identified the key requirements to be achieved, before splitting each into their own component. Doing this allowed us to target each requirement individually, and following this, integrate 2 or more components into one to simplify the system. The motions components consisted of a system to stop the ball for at least 1 second using servos to block their path, a brake beam sensor to control the timing of these servos, and an independent motor at the exit of the box which controls a turntable. This is controlled by a motor driver, creating a pulse width modulation signal to rotate the bottom disc at 15 RPM and release 1 ball every second. Additionally, there are 4 LED strips located in the box, all controlled separately with the Arduino.
The circuit consists of an Arduino, 4 WS2812 LED strips, 2 5G servo motors, 1 stepper motor, and 2 IR sender-receiver pairs, all being powered by an external power supply, represented by a 9-volt battery here due to design tool limitations. The servos will stop the marble at 2 points within the box and hold it there for 1 second, before releasing it and letting it continue along the track. The servo IR assembly operates as follows. 1. The marble trips the brake beam sensor. 2. The marble is held in place for 1 second by the servo arm. 3. The servo arm swings down, releasing the marble. 4. The marble continues along its path, and then 5. The servo arm moves back up to block the next marble.
Soldering it up was quite challenging. With over 20 wires being connected to the power board, the biggest challenge was wire management, as in addition we had a lot of power wires and data wires. This was solved through a combination of heat shrink tubing labeled with Sharpie that grouped several sections together. For example, for all the servo wires we had one own group, and all the IR sensors we had another group. And within these groups the separate parts were further wire managed with zip ties. We also faced a lot of challenges while building the box along with structures team, such as we were required to change the back wall since it was not flushed to be mounted onto the big board. We solved this issue by using a new piece of board and angle grinding the screws that were sticking out so it can be mounted onto the big board.
For the servos to actuate correctly and the LEDs to function while the stepper motor spun at a constant speed, the Arduino Uno had to be programmed in such a way so that they would all work simultaneously without blocking one another. Initially, the turning of the stepper motor was achieved using functions that blocked the LEDs and servos from working correctly. As a result of strenuous troubleshooting, we fixed the aforementioned issue by turning the stepper motor 1 step at a time per loop of code. And after making a clear plan of what should be actuated and when, relative to each other inside the box, the software was mostly written by the comms team, who received some assistance from the motions team. Before we had finished wiring and positioning the components, a detailed pinout diagram was given by the motions team to the comms team to allow them to finalize their programming before the box had been completed.
Although we completed the circuit and tracks, we have failed to complete the mounting inside the box. In the future, we shall improve our time management by sticking closer to our Gantt chart. We will also use CAD more extensively in the future as it is easier and quicker to implement. Our method of making the track pieces by hand was also very time consuming and contributed to falling behind. Lastly, we had difficulty working cohesively as a single unit with the other teams. In the future, we should communicate more clearly with the other teams to remedy this.
Dun 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 dun. It's like Intel.